Good morning, everyone. Welcome to Evaluating the Mobile GIS Landscape. It is, as Claire mentioned, the first of a series of webinars we're going to be running throughout 2016, and this first one is intended to be an overview of mobile GIS, what it means for you, how we can help you in terms of getting your workflow into the field and looking at it from a cost-effective point of view. So just quickly a bit about who we are as a business. MGISS, or Mobile GIS Services, we call it MGISS. We're based in Liverpool, and we deliver a full range of solutions and services to help businesses capture, maintain, analyze and visualize geospatial data. What our particular focus is in specializing in enabling spatial data in the field and making sure we can provide a seamless, cost-effective workflow as we can. We aim to deliver a return on your investment across a single project. We do this by a series of steps which include really listening and understanding your requirements as an end user, as an organization, and understanding the application for which you're going to deploy data in the field. Our view is independent, so we are platform agnostic, we are supplier agnostic, and we like to give a whole of market view. We obviously have our partnerships as anybody else does, but in terms of what we focus on, what our specialism is in, we are completely independent. And what that means is we can consider the most cost-effective workflow for you, software for you, hardware for you, and combine it into a solution. As part of the process, you need to build a business case to get investment into mobile GIS. And what we aim to do is try and reduce your risk throughout that process. And not just as far as delivery goes, but also supporting you throughout the project lifecycle. So really kicking into the theme of the presentation, we want to try and determine which mobile GIS workflow is best for you. And we've really come up with a question to determine what this is. So are you connected? Are you disconnected? Or are you occasionally connected? So it's not a personal question, and really leads on to try and determine what type of mobile GIS is best for you. So what do we mean by connected? Well, a connected application generally involves a consistent internet connection. Typically a web application running on a mobile device or a tablet, but you are reliant on having connectivity at all times. So if you haven't got a connection, you may not be able to see the application, any of the functionality or the data within that application. Not ideal really when you're out in the field. You can certainly lose a lot of time, and you generally find that these type of completely connected workflows are very rare nowadays, and it's not something that we would recommend if we were delivering a solution for you. A disconnected workflow is what we would class as a more traditional type of mobile GIS. Typically you don't need an internet connection in the field, and that's because your data is uploaded or synchronized with a mobile device at the start of each day or week, or at the start of a project. Because the software is then installed directly on the mobile device, all the required functionality is supported within our application, whether you're just simply displaying data, whether you're querying or editing data, whether actually you're doing a full mobile GIS data capture project. Typically with a disconnected workflow, you then return in to the office at the end of the day or the week, at which time you then download your mobile device to a desktop PC. Or maybe you do it from home and you email the resultant data back to the office. More recently, some of the disconnected software packages have got connected capability via Dropbox, which means that you can use some of these file sharing applications to send data to and from the office. And we're increasingly finding that our customers, or we're having to support this type of capability within a disconnected workflow. Typically, this is what most of our customers currently use in the field. With a disconnected workflow, software tends to be license-based. What you get is, within these more traditional applications, because they've been developed over a long period of time, they are very mature and have a whole host of mapping functionality available. Typically, GIS right through to surveying capability. We've given a rough cost depending on the type of module that you purchase. Some of the basic modules for traditional software can cost as little as £250. If you're then going up to more survey type applications where you're wanting high-grade GPS connected into your workflow, you're then looking at the higher end of the license costs. Again, in order to support these products, the software developers, vendors, and people like ourselves who support these products generally provide an annual software maintenance program, which allows you to keep up to date with the software and receive online email and telephone-based technical support. So we support a number of different applications. We're probably most widely known for Digitera, which is a modular, disconnected software program. We also support a number of end applications running ArcPad, which is an Esri or part of the Esri product line, and Terracing, which is a Trimble product for mapping and surveying. More recently, however, people were suspecting that these disconnected workflows were going to be a thing of the past because Microsoft, in their wisdom, had dropped support for its Windows mobile or Windows embedded operating system. But just a couple of months ago, Microsoft have actually announced that they're extending support for the Windows mobile or Windows embedded operating system for a further 4 years. So what that means is that we're seeing a lot of these legacy applications being developed further, and we're certainly in the process of continuing to support a lot of customers wanting to use the functionality which exists in these products over some of the newer entrants into the field. The final category is what we call occasionally connected. And this type of workflow we feel offers the best of both worlds. And what do we mean by that? Well, if you've got an active internet connection, so you're running a device in the field which is connected to the internet, it allows you to send and retrieve data and mapping for viewing and editing in the field, either via a cloud, a public cloud, a private cloud, or your own secure server. You might receive jobs at the start of each week, or you might just want to send back data remotely from the field. However, if you then find yourself disconnected, the application and all the data and workflow within is cached locally, so you can continue to work whether you've got an internet connection or not. Similarly, all the application functionality works in both connected and disconnected mode. And then you only have to synchronize the data when you've maybe got a Wi-Fi connection or you're in a good cell phone coverage area. More and more nowadays, however, and a lot of software is following the same model in that it's being subscription-based. So it's more of a pay-as-you-go model for software as opposed to an upfront license cost. Typically, a lot of these applications are cloud-based. And what that means is that they might have limitations in terms of being secure and having capacity to have private cloud. So some local authorities, for instance, or larger organizations might have difficulty in serving these applications to the field. And because they're newer to the market, they're not as mature in terms of the level of functionality that you get. So you might find you've got basic mapping capability and the graphical user interface is really nice, but it just doesn't come up to scratch when you're trying to do some of the higher end mobile GIS applications. In terms of cost, you're looking at around £15 to £20 per user per month. So an advantage to this means that you can spread the cost of the application over a project and the lower upfront costs. There are an increasing number of these applications on the market. Certainly the list below is not exhaustive by any means, but these are typically the applications that we're finding ourselves increasingly supporting in the field. If you're an Esri user, you might find yourself using the Collector app. ArcPad is in this list because you still have the occasional connected capability with ArcPad alongside ArcGIS for server, and we are increasingly supporting these type of occasionally connected applications using ArcPad alongside that ArcGIS mobile. Some of the more commonly used applications include Trimble's TerraFlex application, TerraGo Edge, which you may have heard of. Another one which isn't on the list is an application called Fulcrum. We're finding ourselves from a hardware point of view supporting these products. But alongside that, we're also developing our own pick and mix custom deployments. So again, it's something you mightn't be familiar with, is we actually develop our own custom mobile GIS software applications, which I'll come on to later. So you're perhaps using this best of both worlds. We're certainly at a point in time where technology allows us to have all this capability. So this is Bill, and Bill is occasionally connected. Bill does have an active internet connection, so we can retrieve and send edits to the cloud from the field. However, Bill can still edit data when he's not connected, as Bill has cached data. Bill is smart. Be like Bill. Excuse the pun. So moving on to, not only the fact that you as an audience have a wide spread of applications, capability, trying to determine which workflow is best for me or for you. So as part of our process for trying to understand your requirement, we ask a series of questions, and this is just the flavor of the questions that might allow you to determine what's best. So, will you have a constant, reliable internet connection in the field? Typically no, but if you're working on a single large site, so for instance a large retail complex or an industrial site that has good Wi-Fi coverage, or more specifically an urban area where you've got a homogeneous Wi-Fi environment where there's plenty of hotspots allow you to connect to the internet, you might then find that a connected workflow can work for you. But because these are sort of an exception rather than a rule, typically we're recommending another way forward. If you return to the office each day, at the end of each week, or frequently enough to only have to download data, not rely on an internet connection to send and retrieve information, then what we would more likely recommend is a disconnected workflow. It's certainly the most cost-effective workflow from our end because you're not having to deal with remote synchronization, any IT infrastructure, or data plan costs. And again, this is sort of making up the higher percentage of what we're currently involved in as a business. But an increasing requirement, and certainly those from larger field teams or organizations deploying larger field teams in the field, is the need to send data back or to receive data remotely while you're on site. And this is where we would determine or recommend an occasionally connected workflow. If you're in a larger organization, then GIS systems might be corporately provided. You might have an IT department that supply or provide mobile data plans as part of a mobile deployment. If you're one of these customers and need to send data back, then what we would look at is a more complicated mix of both disconnected and occasionally connected apps, really to suit the end user. So depending on your requirements for accuracy, for the level of workflow, for integration with some other business process, then a mix and match approach might be most suitable for you. And certainly the wider benefits to be gained from mobile GIS in an occasionally connected environment far outweigh the data costs involved. So at this point we wanted to introduce just a quick poll into the presentation. It's a case of us asking you a question. So what you should be able to see shortly is a question on your screen, and what I'd like you to do is choose one of the options. So it just gives us a flavour of your existing workflow as is as an audience. So we leave that open for a few seconds so that you can answer the question. We'll then close the poll, and then you'll be able to see the results that we share back. Okay, so I'm just about to close that poll. I'm actually going to share those results back with the audience now. So an interesting spread, typically that reflects what we find within our customer base is that the higher proportion are using a disconnected workflow. An interesting statistic is though the level of pen and paper still there in the field, and at a very basic level, that's what we as a business are trying to promote, is simple, easy to use workflows to try and remove the double handling of data when you're capturing information with pen and paper. In fact, we still see it as one of our largest competitors. Okay, so if we've got time at the end, we will have another poll regarding more specific software usage, but I'll continue for now. So as part of the initial conversation with you as an end user or application, we as MGISS try to determine what type of workflow is involved. If you remember, as part of the agenda, we talked about the differences between data collection and data maintenance. Another term for data maintenance is asset inspection. And the main difference between these two types of data capture is when you're going out and performing or undertaking a data collection exercise or project, this is typically where you are positioning assets in the field from scratch. So you're basically working on a blank canvas. An example of that might be a new tree survey. There's a newly refurbished water main or new water meters being put in the ground, and you have to go out and capture to a level of accuracy the position of those assets and attributes regarding their condition, materials used, and so on into a database. When you are performing an asset inspection or data maintenance exercise, typically those positional and other attributes are fixed, so that the amount of information you need to have access to edit in the field is much smaller. You might still want to view the captured asset, but it might just be a dumb layer in your mobile GIS. So there is a subtle difference between what we class as data capture or data collection and data maintenance or asset inspection. And that does have an impact on what we would recommend in terms of your hardware platform, the software you use, the complexity of the workflow, and how you interact with the data. We then look at other requirements at either end. So you may well be an Esri customer or a MapInfo user, CAD Core, any of the mainstream GIS. You might also be using an open source approach, including QGIS. You might be interacting with a CAD environment from Autodesk or similar, or you might be wanting to just use something like Google Earth to retrieve and share information that you capture in the field. So the key point within this is we can support and provide seamless workflows for any end use and any of these GIS formats. As part of that back-end requirement, you might also need to produce a reporting interface which provides asset-specific information on or in a PDF format that you might want to share with a client or a contractor. You might also then, as part of a mobile GIS workflow, want to be able to have a dashboard which is web-based, and that might show the amounts of information that's being recorded and might allow you to interact with your field operatives in the field, see how much data is being captured, what needs to be done. And increasingly we're finding that we're being asked to incorporate some elements of web GIS or dashboard capability into a solution. So we can engage and provide any or all of these components as part of a complete solution or as a plug-in to an existing GIS environment or data workflow that you currently use. I also felt it useful, certainly within this just general overview, to have a consideration for accuracy. And what do I mean by accuracy? It doesn't necessarily relate to the use of GPS or GNSS equipment. It might just relate to how accurately you're wanting to record data in the field, and that can determine the type of solution that we would recommend. Very often, an initial requirement might be for a really high level of positional accuracy, but when you determine or go deeper into the solution or determine the costs involved to look at a high-end mobile GIS solution, it then can sort of drill down into, well, what accuracy do you really need? You might find that actually, when you look at a high accuracy solution, certainly with some of the available technology in the market, it doesn't necessarily have to mean higher cost. And I'll just explain what that means in the next few slides. So here's a typical environment where you might have to record assets. A suburban street, you could be recording assets such as the trees, the lamp columns, signage, curtilage, or it could be buried services on the ground. So when we talk about accuracy, what does it mean in the real world? You can achieve a range of accuracies within a mobile GIS workflow, but that dictates the type of platform and ancillary hardware that you might need, such as GPS. You might see most of this detail on a map, such as Ordnance Survey, and that means you can pretty much use the map to determine where the asset is, but you are reliant on the accuracy of that map itself. So with GPS, it gives you an absolute position in the field. If it's a water asset, or you're wanting to determine both X, Y, and Z position, you might need to look at the higher range of GPS accuracies in and around 10 centimeters or below. A typical sub-meter system, you're looking at an accuracy determined of about 60 centimeters. But by plotting something within that accuracy range, you might find that it's putting it in the road as opposed to in the footpath. So it needs to be considered at the start of a project. In and around the 1 meter level, again, has the same impact potentially in the data, particularly when you're trying to determine one asset relative to another in close proximity, or you're needing to relocate a feature over time. Then we move into the sort of lower levels of accuracy that you can determine with a smartphone or a tablet device. And we've also categorized these accuracies into 4 separate. Moving from the highest level of surveying type accuracy, we would determine as being that requiring less than 10 centimeters in real time or post-processed. Mapping accuracies tend to range from 10 centimeters up to 1 meter, and there are a number of different technologies and correction services available to allow you to achieve a mapping accuracy. For those of you who've not heard of prosumer, it tends to be more for the professional consumer, where you might want to augment your tablet or your smartphone or something similar with a better level of positional accuracy to give you down to between 1 and 3 meters. And at a consumer level, which could be your iPhone or your Android phone or your Windows mobile device, without any augmented GPS, you're only really going to achieve around about 5 meters in real time. So obviously that gives you an illustration of what you can achieve, or what's required to achieve that. But more often now you'll hear us as technologists talking about GNSS as opposed to GPS. So where GPS is a more traditional term, it's actually part of a global navigation satellite system, and that's what GNSS stands for those of you that didn't know. And there are a number of satellite constellations that now sit within the GNSS environment. Our GPS, or Global Positioning System, is the American system. It's been around for a long time, and that forms alongside the Russian GLONASS system, or their own global navigation satellite system, the more commonly used GNSS positioning services available. In the UK specifically, we have full access to both GPS and GLONASS, and the combination of GPS and GLONASS satellites means that you get better coverage in urban areas, under tree canopy, or in difficult environments where traditionally GPS only devices might have struggled. Certainly a lot of our customers are now using at least GPS and GLONASS. GNSS in its truest form also includes the BYOD satellite constellation, which is owned and operated by the Chinese. Currently fully operational in the APAC region, and we will have worldwide coverage within a few years. But in Europe, we're also developing our own constellation of satellites called Galileo. And although about half of these satellites have now been deployed, many are still not actively in service. You can, and some receivers can pick up test Galileo satellites, but it's not going to be fully in service until around 2020, according to the latest news from the European Space Agency. So any receiver that's capable of picking up signals from these satellites is bound to give you better coverage and redundancy in the field, thereby increasing your performance. We also have a number of different free and subscribe or subscription-based correction services. You might have heard of a service called EGNOS. EGNOS is part of a global satellite-based augmentation system, and it's one of a number of freely available correction sources that you can pick up with a compatible GPS receiver, and some tablets and smartphones already have this capability built in. Typically with an EGNOS correction in this part of the world, you can achieve reliable sub-meter accuracy, generally down to the 0.6 of a meter level. The limitations with this type of service is based on a footprint, so you don't have worldwide coverage, and you also need a line of sight to what is effectively a geostationary satellite broadcast in this correction. It's much more reliable than it used to be, and certainly with some of the receivers, the external receivers that we're providing, they're getting a lot out of the SBAS augmentation down to the half meter level, 0.6 of a meter in real time. That's typical of what we're finding. There are other subscription services available from a number of sources and suppliers, including Network VRS and Virtual Reference Station. You can also pick up satellite correction services supplied by the likes of Trimble and Hemisphere with RTX and Atlas respectively, but these are paid for services. Typically where internet coverage is poor, or you've got no capability to pick up a sub-meter correction in real time, this is where we would recommend one of these subscription-based services in conjunction with a mobile GIS solution. Often they require some additional antenna, external antenna or firmware upgrade, and that generally means either a return to base or paid for upgrade to an existing piece of hardware. But what it delivers is a scalable accuracy range, anything from 1 meter, sub-meter down to 1 centimeter. So you do have this real-time single receiver scalability with a lot of technology on the market now. Main advantage is convenience, so you don't need to set up a base station, or you don't need to provide any post-processing capability within your software. You do have to consider a subscription cost, which varies depending on where you are and the level of accuracy required. Some of these correction services also require an internet connection. Those that are satellite-based typically work well without an internet connection. And you don't get full worldwide coverage, although increasingly that is the case where you can actually use these correction services anywhere on the planet. So hopefully that sets the scene for accuracy, some of the terminologies that we use within the industry. We're starting to class GNSS as an external sensor as opposed to just a positional receiver. And as an additional augmentation in the field, you might find that you would want to incorporate a laser rangefinder or some other type of sensor within your workflow. So more and more we're getting asked about the type of Bluetooth receivers, professional level Bluetooth receivers that are available to plug into an existing tablet or smartphone or workflow, or something like a laser rangefinder which you can bolt onto a device. And what that means is you can stand in one location and remotely position and record GPS coordinates of something that you can't access in the field or directly. So you've got this modular approach to mobile GIS existing now. And some examples of the receivers that you can plug and play include the Arrow series, which are a series of 3 receivers that take you from GPS only through mapping grade capability right up to dual frequency centimeter level capability. Also, you've got the Trimble R1, which is a single pocket-sized receiver and antenna combination, Bluetooth enabled, link to any type of device, and deliver scalable corrections, either real-time, sub-meter down to centimeter level, into a mobile GIS workflow. There are some considerations as regards software, but if this is the type of system that you're interested in, certainly we can have a discussion around what's most suitable for the application. More traditionally, on the right-hand side of this slide would be something like a pole-mounted smart antenna, which can pick up any satellite-based or network-based correction in the field, delivering survey-grade centimeter-level accuracy in real time into a mobile GIS workflow or survey workflow. It's pole-mounted generally in order to achieve higher levels of accuracy in 3 dimensions, X, Y, and Z, and also to give you a better reception above your head on the ground. More typically, the pocket-sized receivers are mounted on a belt pouch or in a backpack. So you can mount these Bluetooth receivers on a pole to improve your reception or reception of signals in limited environments. Again, we provide and promote a number of different all-in-one devices. So some of the advantages of having an all-in-one device is that you're not having to take separate pieces of equipment in the field. They are very fit for purpose, and more often than not now they're incorporating both a high accuracy GPS receiver, camera, laser rangefinder, and software in a single device. Examples of this are the Ike GPS platform or the Trimble Geo7X platform that both have integrated laser rangefinders for remote 3D measurement. Again, you can mount these devices on a pole with an external antenna to receive down to centimeter level corrections, and again customize and develop your own workflow, which might be a custom workflow, it might be a proprietary data capture system. Again, we can provide off-the-shelf and custom solutions and develop the workflow depending on the end application. So just to give an indication of cost, and this is always the all-important question when considering a mobile GIS solution. When we look at consumer level applications, you only really need to consider, a maximum a few £100, which might be a combination of a consumer level tablet or smartphone, some ready to go application, and inbuilt GPS connectivity. Typical advantages are it is low cost. You can deploy it across larger field teams, but on the flip side, generally a lot of these platforms have not been designed for use in the field, or certainly in more hazardous or environmentally restrictive environments, in the rain, for instance, or industry environments. So it's not something we would typically recommend in those application areas. But because you can now purchase scalable Bluetooth-enabled GPS receivers, such as the Arrow series or the Trimble R1, it means that you can plug and play positional scalability into your mobile GIS application. You can share this type of plug and play across a number of different departments. So you might have a single or a small number of receivers that are used as and when required for higher accuracy mobile GIS. And again, this is typical of what we're finding ourselves deploying to our customer base. As you move along the scale into sub-meter applications, the cost does start to increase. So taking the Arrow series, the Arrow series of receivers consists of an Arrow Lite, which is GPS and SBAS only. That comes in at a cost of just over £1,000 as a receiver system. Compare that to the Arrow 100, which is a receiver system will give you down to sub-half meter accuracy in real time. Cost-wise, you're looking at around about £2,000 as a plug-and-play system. Then up to the Arrow 200, which can deliver dual frequency, centimeter level accuracy, but again increasing the cost up to around about £4,000. As a comparison, the Trimble R1 is a single receiver which is scalable, and the cost for which starts at around about £1,700, dependent on the correction service, up to about £3,000. If you're then looking at an all-in-one system such as the iGPS or Trimble Geo7X, typical costs are around about the £6,000 mark. If you're then looking at a pole-mounted, dedicated GNSS system network rover, typical solution costs around about the £8,000 mark. So hopefully that gives you a flavour from a budgetary point of view where the technology is at, and also where the costs are at in terms of deploying these for a single user or multiple users in the field. So I've managed to go through a lot of these slides in an overview detail. And there's a lot of decisions that you need to make, and we as a business are here to help you through that process. So in summary, what we focus on is providing independent advice. It's not whole of market, but it's based on our own experience, both as users of mobile GIS over 20 years, of integrators of both hardware, software and platform, and both through discovery days and hopefully an increasing number of these webinars, we can engage with you as an audience and try to develop your knowledge alongside trying to help you choose the right solution. Now I think at this point what I'm going to do is introduce another poll, because we've got some time available. And our second poll is just specifically looking at the type of software you may or may not use currently. So hopefully you'll see the question appear on your screen now, and we'll leave it open for you to answer for a few seconds if you're happy to provide that information. Again, then we'll share the results of that question, that poll, with you very shortly. Okay, so thanks very much for providing that information, and again I'm happy to share that with you. So again, there's a good spread of application use here. Again, the interesting categories there are both other and none. So, you know, this is where we would possibly like to further engage with you as an audience to find out, A, whether you're looking for a specific type of workflow or software, and B, whether we can help you along that journey. As I said, this is the first of a number of webinars that we're hoping to run throughout the year. And if you need to ask any questions or get in touch directly, please feel free to contact us at any of the available numbers by email, or visit the website to see any of the products that I've talked about in brief detail today. If you've got a specific requirement to for a webinar or type of product or workflow you'd like to understand in more detail, please let us know, and it might help us determine our schedule of upcoming webinars for the rest of 2016.
So that concludes this morning's webinar. We'll hope you join us for more as we run through 2016. The webinar has been recorded, so if anybody would like to see it again or know somebody who might be interested in it, we have the link available which we'll send out for you to access. But meanwhile, thank you for joining us this morning, and we hope to see you again soon. Thank you.
Thank you.